Do you able to see my slide?
Yes, sir.
Okay, thank you. Let us continue. On the last week, we started module 5, and it is dedicated for the intermediate representation. So on the source code, in the process of designing compiler, on the source code, we perform lexical analysis. Then we perform syntax analysis, that scanner and parser we discussed in detail. Now in this module, we plan to perform tree address code generation and semantic analysis. On the last week also, we discussed the tree address codes, what are the different format of the tree address codes. And after looking at those tree address codes, so we are also sure that since there are only a finite number of tree address code, so corresponding to each tree address code, if we have a list of machine level instructions, then after converting the source program to tree address code, it will be very simple to generate the machine level code when we will substitute each tree address code by its representative, so list of assembly, the assembly or machine language code. Okay. Now also we started more elaborate discussion on the symbol table. So in this week also we will continue on that one. To talk about the symbol table, I mentioned that the symbol table creation starts at the first stage, that is lexical analysis stage, and it goes up to the code generation. Mostly it is the integer, or in general mostly it is the constants, the identifiers, including the name of the variables, name of the functions, are stored in this symbol table. Today we will discuss some examples, more examples, and different variations of the examples, and we will see that when there is a structure definition or it is not a basic data type, for that one also symbol table stores some information. That way symbol table interacts with all the modules, but primarily it gets populated during syntax analysis, semantic analysis, and of course lexical analysis stage. On the last class also we looked at the symbol table where there are columns, like first column is the name of the identifier or name of the function, followed by what is their data type, followed by what is the scope or type, followed by what is the offset, how much memory is required, and followed by what will be their location. Now in more uses of symbol table includes, so various string constants you can also store apart from integer and floating point constants. The string constant includes various strings that you are familiar with, which comes within double quote. So target level information is also you can store in the symbol table. In some programming languages, not for C, C++, you can also store that keyword information. So for those programming languages where keywords are stored in the table, basically during the scanning stage or lexical analysis stage, so it considers everything as an identifier. The latter point of time, perhaps it is mapped to the keyword. Otherwise, you know, for C, C++ also, that reserved keywords are also nothing but the with the same property as the identifier or name of the variable. It is only the situation during the implementation in scanner or parser we are placing those tokens or the patterns above the identifier. That's why first it will check for whether one character sequence or patterns is belong to some keyword or not. If not, then only it will check whether it's an identifier or not. Okay. And in the type definition, so the built-in functions are there, but apart from that one, if there are some derived function, then definitely we will store that information also in symbol table. Some aliasing information, namespace information, so those things are also stored in the symbol table. So let us explore with examples. The first example is very simple and straightforward. It is addition of two variables by calling a function. So there are two functions, main and function add. In the main, as usual, it is taking integer argc and character star argv as an input. Its return type is void. That's why here return is without any arguments or variable. So it's return semicolon. There are three integer variables I am declaring inside function main. I am assigning them. I am calling the function add. Inside the function add, I am adding them, storing in some local variable and returning that value. Okay. Now, if I look at this source code only on the left hand side of this vertical red line, by looking at this, I can figure out that what are the identifiers. As you remember, the first symbol table ST will be for the global variables or global functions. Of course, later we will see global class, global structure. So whatever is global, for that there will be one symbol table. So in the first symbol table, name is st.glb, just to indicate that this is global. Function add, its scope is global, so that is added. Function main, its scope is also global, so these two are added. Now what is the type? So first column indicates name, here it is mentioned. Second column indicates type. Third column indicates category. Fourth column size as per the memory requirement. And final column is offset. So when it will be loaded in the RAM and it will execute, and say operating system provides that, okay, this is your start address, you should stay here and do your operation, then considering that as 0, then how it will go. Or say if I assume that variables will start from this particular location, so how much I need to add in order to align them or in order to get the memory. So that is offset. Now for the function add, it is taking two integer variables x and y as input and outputting another integer value or returning another integer value. So its type is int cross int. This int cross indicates that two integer arguments maps to int. This right hand side indicate that this is the return type. Similarly, for function main, it will be argc is of integer type, argv is of double character type, but I mean two-dimensional character type, but its property is one star another square. So array within parenthesis star comma character star. So regarding this kind of type, we will discuss in more detail in the type definition part, that will come later. But for the time being, I believe that if you look, then you can also understand. So it is two-dimensional array. So one is star, comma, character star. And it maps to void because main is not returning anything. In the category part, this third column, add and main both are functions. And there is no memory requirement for these two functions. By this memory requirement, only for this function there is no memory requirement. Like for variable or the identifier, I need some memory to store its content. Similar to that, for function there is no requirement, that's why it's 0. And since there is no memory requirement, so offset is also here 0. Okay. Now, if I look at the function main, then corresponding to this function main, there will be one symbol table, and that is here. What is inside that function function main? So two variables, argv and argc, they are actually parameters. So the type of argv I discussed here. So array star comma character star, and argc, you know, it is integer. Both are parameters, so param. Now they are taking 4 bytes, 4 and 4. After that one, 3 integer variables a, b, c. They are local variables, that's why type is local for 3 a, b, c. All 3 are integers, so it's int. Memory requirement is also 4 here. Okay. Now one interesting fact regarding the order of the identifier in this symbol table. Now I think one thing is clear to you, that this symbol table you are writing inside the compiler. So whatever the convention you wish to use, that's entirely your responsibility. You can do that one. Usually what is done, that I should not say usually. So two different kind of representations are there in the context of the symbol table regarding the order of the variables. That parameter of course will come first, but the parameter you can scan either from left to right or from right to left. In this case for st.main, so argv is coming first, that's why the scan is from right to left, then argc. Argv first, then argc. But I have examples also, later I will show you that it can scan from left to right also. Then argc will come first, then argv. Okay. And also the convention wise, sometimes it is considered that considering the first local variable starts at 0th position, all other local variables will go negative and all parameters will go positive as per their order. That's why you see here 0 for the first local variable a, -4 for b, -8 for c. T1, T2 I didn't discuss, I will come to that later. On the other hand, for argc and argv, it is +4, +8. Again, this is also a convention. You may think that, okay, whatever will occur first in my symbol table, I will consider that as my baseline or reference frame. Then you can make it as 0, then it will be 4, then it will be 8, then it will be say 12, like that it can go. You may think that, okay, it will start from 0, then I will give say negative -4, -8, -12. It's up to you. And my point is that whatever the convention you will use, please stick to only one convention. And of course you have to. And why I am suggesting that it can be say left to right here scan, or it may be the first local variable will be 0, then one positive side, another negative side, or can be the first occurrence of the variable in the symbol table is 0. This is primarily that you will be dealing with this symbol table, so you can have your own convention and implement it accordingly. So that flexibility can be there. So here, as I mentioned, for parameters right to left, and I am assuming that first local variable is going to be at 0th position, but later I have examples. I will show you that it can be parameters from left to right and variables followed. Maybe the first occurrence of the variable in the symbol table will be 0, and you know that only two operations are there in the symbol table as of now what we discussed. Whether the variable is present, so symlook or symlookup, and when you will go for symlookup, then you will cross check with the existence of the variable name, or if you do some aliasing, then you will check with that aliasing, and if it is not present, then you will insert that one. Okay, so that scanning left to right for the parameter, or say right to left for the parameter, or offset, whether it is starting from 0 or say first local variable is 0, doesn't matter much. But what matters, and of course it will be always, that first parameters will come after the local variables as per their ordering. Reason is very simple. In the scanning stage, you are scanning from top to down, left to right. You are using some scanner and also interacting with the parser. And whenever you will look at one variable, then you will query that whether that variable or identifier is exist or not. If yes, then fine. If no, then you have to make an entry. Okay. Now let us look at this 3 address code part. I believe that is the most simplest one, the 3 address. So here integer z I declared corresponding to this function add. Now x plus y is assigned to z. That I can consider that there is T1. T1 is compiler generated temporary file. We discussed in detail about this one, and also we'll discuss when we will go for this implementation. So T1 equals to x plus y. I can have one compiler generated temporary file, and then T1 will be assigned to z, finally return z. Okay. Now for main, a equals to 2, b equals to 3. So directly I can go for 3 address code, or say 2 is assigned to T1, then T1 is assigned to A, 3 is assigned to T2, then T2 is assigned to B. Then I am writing parameter A, parameter B, calling the function c equals to call add, comma 2 to indicate number of parameters. Now you know. So here everything is in the format of a 3 address code. This is the format for 3 addition and for binary addition. This is the format for copy statement. This is the return statement. This is the function call statement. So these formats are there. Now this implementation, when you can also see some redundancy, because you may feel that okay, why is it required that 2 will be say assigned to T1 and then T1 will be assigned to A. So is it necessary? While you are generating the code, I mean the 3 address code, you may consider that okay, let us not optimize during the code generation, generate as much code as possible. And when you are generating these temporary variables, compiler generated T1, here T1 and T2, so those will make an entry to the corresponding symbol table. Here you see st.add T1 integer data type temp 4 minus 4. Now you know this T1, or in case of st.main, T1 and T2, these two variables are not present in the source code. So it is you, when you are writing the compiler, in order to generate the 3 address code, you are declaring those variables. So what will be the data type and what will be the scope? Everything will be defined by you, and you will make an entry to the symbol table. Usually it is said that when you are generating three address code, do not think about the optimization, because by looking at this you may argue that, okay sir, why there is a need of T1 and T2? I can directly go for a equals to 2. I completely agree with you, because I also know that if there is T1 and T2, then extra assignments are there, so time reduces, compilation time increases, and 2 more memory locations are required, T1 and T2. But suggestion is that do not go for this optimization. Let us have this. We have a lot of optimization stage that we will discuss later. But one small optimization right now I can tell you, that is called as the p-fold optimization. In that p-fold optimization, going back, so if you find some statement like this, say T1 equals to 2 and equals to T1, and there is no other use of this T1 further, then you know that this T1 is redundant. So directly you can write equals to 2. But before that, you have to make sure that T1 has no further use of that one. After doing that analysis, how to do that analysis, that we will discuss later. You can go for optimization, and in this optimized case, you see that there is no requirement of any temporary variable, and you have this three address code. Accordingly, symbol table also is not having any temporary variables. That is fine. I think it's straightforward and very simple. Now, if it doesn't mean that we do not need that compiler generated temporaries. Yes, we need, but for this application or for this source code, for this example, we do not need that one. Let us see some other examples. So here another situation, that same addition operation, but instead of integer, I am assuming all the variables are double in nature. So that's why you see I am just highlighting only the modified part. It's double cross double maps to double. Main is void and void. Both are functions. Since they are double, so the memory requirement is 8 bytes in all the cases, and rest of the things are same. Okay. Now going to the next example. This is an example of swap. Now you know that this is a very basic example to demonstrate that pointer or call by address. So in this case, the main function is swapping the value of a and b. That's why it is passing the address ampersand a, and swap function receives those in terms of pointer. Okay. Now if I look at the three address code first, then for the swap, so one local variable t has declared, so t equals to star x. Now you see in the three address code, it has nothing to do with the declaration part. It is only for those evaluation. So t star x semicolon, it comes directly in the three address part. Then x star x equals to star y, then star y equals to t, then return. Return is void here. For main, a equals to 1 from here, a equals to 1, b equals to 2. Then you can do one thing, that this ampersand a and b is going to T1 and T2. Again, I am suggesting this T1 and T2 are compiler generated temporaries, which means if you are writing the compiler, then it is your responsibility. So what will be the data type for T1 and T2? How you will use that one, it is entirely your responsibility. And as you can see here in the three address code, there is no scope of declaring that T1 equals T1 is say pointer type, T2 is pointer type. It will be in the symbol table, that I will come later. Now that ampersand a and ampersand b, I am copying to T1 and T2. I am assigning T1 as one parameter, T2 as another parameter, and calling the function swap, comma 2 indicates that there are two parameters. That is the format for the 3-address code. Finally, return null, so it's just return. So swap and main, both the functions is returning null. Okay. Now coming to the symbol table. So again, there is a global symbol table, st.glb. Function swap, it is taking two arguments, int star x and int star y. So int star cross int star maps to void here. Main is void maps to void. Both are functions, no memory requirements, hence offset is 0. Looking at the swap, so I have two parameters. Again, it is reading from right to left. That's why y is coming first, then x. Now you know that this variable name is y and x. Data type is int star. So int star here, int star here. Both are parameter. In short, PRM was written. Actually, it will be parameter. And t is my local variable. Its data type is int, and that is LCL. It is written. Actually, it is local. All are with byte size 4. And as I mentioned earlier, that it is your responsibility. So I'm starting from 0, 0, 4, 8. That is convention. Please use only one convention and stick on that one. Separately, you can think of that as if this is 0, this is minus 4, and this is minus 8. That is also fine. Now coming to stmain, two variables a and b, integer a and b, both are integer, local, memory requirement 4, offset 0 and 4. So for this offset calculation, you see that the first is 0, and since a will take 4 bytes, so b will start from 4. So 0 plus offset of this one will give you this plus this will give you this 4. Similarly, this plus this will give you this 8. Like that it will go. I think that you noticed, and it's trivial. Now, for these two variables, T1 and T2, which are compiler generated, I mentioned that these two are directly generating during this 3-address code generation. Before that, there was no existence of T1 and T2. So you have to make an entry of T1 and T2 in the symbol table. So T1 and T2. Now by looking at this application, you know that it is of integer star, both. Although here it is mentioned as local, but you can also mention as temporary. Those are temporary. Actually, it will be temporary. There is a mistake small here. So it is not local. So they are temporary. These two, both are temporary. Temp. They are data type. 4 bytes, accordingly, offset is also adjusted. Now you see that this is my 3-address code and this is my symbol table. Collectively, it stores the information of the calculation as well as the data type. In source code, the data type was mentioned explicitly, but here in 3-address and in consultation with the symbol table, I am having the complete information. If I do not have that together, then you see that how do I know that whether say this a equals to 1 or b equals to 2 assignment will be an integer assignment or floating point assignment? That I will understand only when I will consult with the symbol table. So you see the requirement of the symbol table at each phases of the compilation process. Okay. Now here is also another situation that you may think of, that without say declaring, if I directly use, so here you can see swap is occurring on top of in void main. So whenever I will call swap, before that one, swap is already entered to my global symbol table. So I am coming from top to bottom. I encountered swap first, that's why I entered swap here. And after looking at main, I am entering main here. Now when I am, say, looking at the source code, then I see swap here. What is swap? I do not understand, but I consulted the global symbol table. I see that, oh, it's a function type. It's fine. Now, if it is the situation that this particular function swap is defined after, say, void main, then after encountering swap, I'll be confused because corresponding to that swap, there is no entry in the global symbol table. Then my question will be, is it a typo? Is it an error? Or swap is something it should be it should be there. Now in your compiler, either you can give flexibility, okay, if that kind of situation happens, then you assume that probably swap will come later and move on. Or you may think that since I didn't see the swap previously, so it's an error. So that's why in C compilation, in C programming language, either you define the function before its call or you declare the function. So whenever you will declare something like this, void swap integer star x comma integer star y semicolon, or optionally you may remove the variable name x and y. Now you see that whenever it will see this one, then this variable name is optional. What is required to know that, okay, this is a function swap. It will take two integer star parameters and it will return void. And if x and y is absent in the function declaration, I am talking about the declaration because I am assuming void swap will be defined after void main. Then from that declaration also I can extract this much information: name of the function swap, parameters int star cross int star maps to void, it's a function 0 0, right? That is the reason in function declaration why say name of the variables are optional. You need only the data type, and for that you understand that if say data type doesn't match, then it will raise the flag. No, this is not the swap which is already declared or you are using, so that matching is required. Okay, so going to the next example here. Now we have one structure data type. As of now, we dealt with integer, say double, and both of them are basic data type. Directly we enter that one. But when I am defining one structure data type, this is the first, you can see type def struct double re double im complex. Basically this is the structure definition for a complex variable, contains two parts, real and imaginary. Both are of double data type. Now after that one, it's a simple addition of complex numbers. This program you know, and also you know here the assignment of the complex numbers or assignment of the structure variables while I am declaring that variable. Program is very simple. Also the three address code. In the function cadd here, what you can see, z.re equals to x.re plus y.re, z.im equals to x.im plus y.im, star rv. So this star rv is my return value. Z I am storing there, and then I am going for return. So here after this, either you can write directly z or you can write rv. So rv is missing actually here, that you can see. Now for the function main, my three address code is that it is the assignment of the structure members. So in the structure complex, there are two members, real and imaginary. Now a equals to 2.3 comma 6.4 indicates that a dot re, real part, is 2.3 and a dot im equals to 6.4. Similarly, b dot re and b dot im, c dot re and c dot im. After that, I am calling function cadd with two arguments a and b. Who are the a and b? They are complex data type. So I am mentioning parameter a, parameter b, and then call c underscore add, name of the function here, comma 2. 2 indicates that I have two parameters to pass to that function. It is returning c, which is assigned here directly, or say you can take one temporary variable and use that one. Then during the people optimization, that will be removed and it will be like this: c equals to this call c add commas 2. Clear? If you have any question anywhere, do not hesitate to ask. Just stop me and ask. Okay. Now, if I look at the symbol table construction, then few things are obvious from our previous discussion, like existence of a global symbol table, existence of a symbol table for cadd, existence of the symbol table for function main, and entry of cadd and function main, function cadd and function main in the global symbol table, since they are global in nature. But extra part what is there is that type definition or structure definition. So complex, as you can see, its scope is global because it's outside of any function. So it will go to the global symbol table. Name is complex. What is this? It's a structure and two members, both are of data type double. So structure within curly brace, it is double comma double. And what is it? It is the type. So it's the type definition. Is the data type I am basically defining, user defined data type. Again, for the definition, there is no memory requirement. Okay, there is no offset. But yes, in this case, you can see that instead of offset, I am giving one information that for further details regarding this function, further details regarding this structure, you should look at the symbol table st.complex. Now for cadd function, complex cross complex maps to complex, it's a function type. There is no memory requirement, and instead of, since I know that for function there is no memory requirement, so there is no question of say offset. So that column instead I am using to point that where can I find the details regarding this function. Details means details of the variables. So it is st.cadd. For the main, it is void maps to void, its function 0 st.main is my symbol table. Now usually corresponding to each symbol table, you can give a name of that symbol table and who is the parent of that symbol table. Now obviously for all the global symbol tables, there is no parent, so you can write the null. But for symbol table st.complex, st.c_add and st.main, so parent is st.global because the declaration of st.complex and then so st.cadd or st.main, so basically those are in the st.global. That's why it is. Now regarding the function, I don't think that I have to explain cadd and main because we discussed that one. Two extra points: the data type is complex, and since it consists of two doubles, so the size of this will be 8 plus 8, that is 16, which is written here. Okay. Now, new thing here is that symbol table for the complex structure data. So st.complex, its parent is st.global. There are two member variables, re and m, both are of double data type. They are local. Here it is mentioned. Data size. Its size is 8 bytes, and offset. If first one is 0, then next one will be 8. Okay. Now, two things I would like to mention to you. Probably in the programming and data structure class, so your corresponding teacher has discussed that in this structured data type, so you know that in the memory, so what will be the total width corresponding to each address, that is fixed, and that is based upon system. Say 8 by 8 or say 16 or 32, something is there. Okay. Now you see that as per this ordering of the member variables in the structure, re and m both are of double type, so no complaint regarding that one. But if it is the situation along with these two doubles, there are there is one character and there is one integer, and if you know that for integer it is 8, for integer it is 4 byte, for double you know that it is 8, and for character if you know that it is 1, then from this symbol table also you understand that first variable will start from 0. Then as per the ordering of the next one double, one integer and one character, what will be the total memory requirement, that may vary, because you know that if say 1 byte or 2 byte is remaining here, then nobody perhaps can use that one. Say for example, if because of the declaration, so you do not have say sufficient or 4 bytes here, then in order to declare one integer you have to go to the next. But if you rearrange this in such a way that it is possible to have one more variable here, then it is possible. So that way you can also control that total memory requirement. I believe that it was discussed in the previous class. And what is the explanation? So it is more clear to you right now. Another point here is that because this structure is defined outside of all the functions, that's why its scope is global, and hence it is entered to the st.global. But it might be possible that this particular structure is defined say inside some function, then it will go inside that particular function and its scope will be inside that function itself, because the symbol table indicates that one. Okay, more we will see for this nested block. In this case you see that it is the sum of the list of integers. It's a simple function if you look at it. So integer a3 and integer isn3 for I equals to 0, I less than n plus I, ai equals to I. So I am first storing that integer, some integer I am storing, and then I am calling the function sum an, and what sum an will do, it will basically add those integers and then return that sum, it will print. Again, very simple program. But extra thing which we added here is that the array, this array, and also what we added is nested block, and you see that inside this for loop here one variable is declared. Now I believe all of you agree with me that the scope of this variable t is only inside this for loop, not outside this for loop. So how that scope information is obeyed, that I will discuss using this symbol table. Now for this, If I go for the 3 address code, then for the sum, s equals to 0 here. Then for I, for this I actually no declaration, but for this for loop I equals to 0, it will be I equals to 0. Then if I less than n, so for this, go to L2. This level I am calling as L0. Go to L2, go to L2, else go to L3. Then I am incrementing I equals to I plus 1, go to L0. Now for this array, as you remember that in order to access that one, so I indicates the index of the array, not actually the byte size. Since it's integer, that's why what I am doing here, I multiplied with 4 at this line, that I am storing in some compiler generated temporary T1, and then a T1 equals to T here. But instead of this T, what I am doing that this T I am giving as T underscore to discriminate between the compiler generated temporary and this one. You remember on the last class I mentioned that I am considering say T followed by some integer constant or integer number as the compiler generated temporary. That is my convention I am using. But there is no guarantee that the programmer will not write a program where say T1, T2 is their local variable. If it is, then there will be a clash or confusion. So again, it is your responsibility to track down that one since you are writing the compiler. And you didn't mention that, okay, so if you are using my compiler, there should not be any variable in your program which is say with the variable name say T1, T2 dot 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 say up to T1000 or so. So I believe you will not specify. You can specify, you can say that one. Then your checking is not required, but again you are restricting the programmer. But if that kind of restriction is not there, then it is your responsibility to check that one. So to avoid that one, it is T underscore 1 that you can see, and it will be local, whereas this T1 will be temporary. Now I am assigning it to it, then S plus equals to T, it will be actually S equals to S plus T1, then go to L1, return S. Okay. Now for main, similarly, I have n equals to 3, first this one, then I equals to 0, then if n less than n, so you know the construction of the for loop. So after the assignment statement, the first argument, statement, then it will check this one, then it will go to the statement, and after that it will come back to I plus I. So accordingly, I wrote the 3 address code, and since there is a function call, so parameter an and call sum 2, that is also mentioned here. Okay. Next, I am printing that is parameter that I am printing. Okay. This is my parameter. You note it down here. Interesting one. And another parameter is s, that is here. Then I am calling call printf comma 2. So there are 2 arguments or 2 parameters. I am mentioning it here. Okay. Now looking at the symbol table, so sum, since it's an array star comma integer, and this is another integer, cross integer maps to integer. It's a function. More details you will find in st.sum. For main void to void function 0, more details you will find in st.main. Now st.main, whose parent is st.global, contains a, which is array 3 int, that is declared here. It's a local. Since 3 multiplied with 4, that's why it's 12. Now I, S, N all are integer, so local variables. N is also integer, and T1 is my temporary, so that all are 4. Now here you see the offset is starting from 0 and increasing. As I said that it is a convention, you pick one and stick on to that convention. It's entirely up to you. Similarly for st.sum, you will have A is an array integer, that is parameter, then n. Now you see that left to right scan I am doing. So int A, int n. So that's why first A is coming, then n. Again I am mentioning that it is your convention, you pick one and stick on to that one. Okay, then I is t_1, t1. So those are here. Okay. The next here, I have more functions. Here in trans, integer A, integer star f integer, integer B, return A plus a B. Rest are very simple and straightforward, increment and decrement. And here in the main function trans x comma increment comma y, x comma decrement comma y. So that you can see here. Okay. Now, when I say go for this is interesting, this part. Okay. Then parameter B for this trans function, parameter B, then t1 equals to call f comma 1. Then t2 equals to a plus t1 and return t2. This is my 3 address code. Increment and decrement operator is very simple. Now in this case, x equals to 2 and 3 for function main 3 address code. Then parameter x, parameter inc, then parameter y, then call trans 3, x decrement y, call trans comma 3, t1 plus t2 return. Okay. Now in this case you see that integer a for this function, only new thing is that this transpose operation, so this trans function, integer cross pointer, integer to integer, that is my pointer, cross integer to integer, it's a function. Rest are simple, integer to integer, integer to integer, void to void. Now for st.trans here, the symbol table contains integer f and b, all are parameter, but f is pointer integer to integer. Now t1 and t2 are local variables that was generated here. All are of 4 size and accordingly offset is arranged. Now increment, decrement and main, I am not going into details because they are pretty simple and following the previous discussions. Okay, so here is another nested block example. So in this case, it's a very simple function, but this is global GBL. Now here there is one local, because of the opening and closing brace, here there is another local, here there is another local. So these locals are inside one after another and one after another. Now they are not differing by the function, but inside one function, it's at the block level, their definitions are changing. Now you know, I am not going into details that inside this P, its value will be only reflected inside this one. When it will come out, then its value will change. How will it change? Okay, how will it change? That we will continue tomorrow because time is up for today. Now up to this, do you have any question? Please let me know. Okay, so if you do not have any question, so let us stop here for today. We will continue on tomorrow from this slide, that when it is not different function but inside of one function, only at the block level they are changing, then how do we manage that one in the symbol table? Okay, so thank you very much.